Hi, my name is Amanda, and today I'll be talking to you about the experiment Spectrophotometric Determination of Iron. In this experiment, you'll be applying the Beer-Lambert law to quantify the amount of iron contained in an unknown sample. In this experiment, you're going to be preparing various solutions. There are sort of two groups of solutions. One will be a standard iron solution that you'll prepare in a 500 milliliter volumetric flask. This contains a known amount of iron. The other flask that you will prepare is the unknown sample, and that will be done in a 250 milliliter volumetric flask. When you've prepared these solutions, they'll be transferred out into a series of 50 milliliter volumetric flasks shown here. The standards will contain different amounts of the standard iron added to the flasks. The unknown will be a certain amount of iron from your unknown sample, and that will be transferred in 250 milliliter volumetric flasks. To the standard solutions as well as the unknowns, you're going to be adding a couple of reagents before preparing them to the markings on the volumetric flasks. The first ingredient that you're going to add is hydroxylamine hydrochloride, and this is a reducing agent that takes the iron from your standard solution in the 3+ oxidation state down to the 2+ oxidation state. The second reagent that you'll add is orthophenanthroline, which will react with the iron 2+ and form a colored complex, and the color being orange, as you can see here. You'll let those ingredients react for about 10 minutes, and then you will dilute them to the mark with distilled water. So to kind of show you an example here, what you can do to sort of speed up your preparation is fill up the flask with distilled water around to where the neck starts, and then you'll add distilled water a little bit more slowly with your wash bottle and fill it up to where the line is on your flask. When you're preparing any solution with a volumetric flask, you want to ensure that you invert several times just to ensure that your solution is thoroughly mixed. Once you have prepared your standard solutions and your two unknowns, you'll then be ready to run your measurements on the spectrophotometer. The spectrophotometer that you'll be using looks like this. It's got a USB cable that connects it up to a laptop computer containing software that you're going to be using to run your measurements. The lamp of the spectrophotometer is on this side, and the detector is on this side. It has a holder that will be able to contain a cell where you'll put your sample in. The cell, or otherwise known as a cuvette, looks like this. It's got a clear side, and it also has a graded side. And you want to ensure that the clear side is facing the detector and the lamp. So it will go in kind of like that. You don't want the graded sides facing the detector and the lamp, since that's going to redirect the light that's going through the sample. When you're running measurements with the cuvette as well, you always want to ensure that the clear sides are clean. So you can always do that by taking a Kleenex and holding it by the sides of your cuvette, and then just giving it a quick wipe. Like that. So we're going to run some measurements. So at the start of the lab, you'll want to start up the Logger Pro software that's located on the desktop computer. Okay. And we have to first calibrate the instrument. So to do that, we're going to go into Experiment and go down to Calibrate and click on Spectrometer. And you'll see a window pop up telling you that the lamp is warming up. When the warm-up has completed, it'll then prompt you to place your cuvette in your device. So you would start off with your blank solution, so the one solution in your standard series that contains 0 milligrams of iron. And then you will put it in the spectrophotometer and then click on Finish Calibration. And after a few seconds, you'll then be able to click OK, and your spectrometer will be ready to run your experiment. You're going to be taking the 0.15 milligrams of your standard solution, and you're going to run this in your cuvette and place it in your spectrophotometer. So then to run your absorption spectra of your solution, in the Logger Pro window, you're going to click Collect. And it'll take a few seconds, but then you should be able to see a graph representing your absorption spectra of iron. You can then click Stop to collect the graph. And then if you want to make it a little bit clearer, you can do various things like take out the rainbow part of the spectrum just by sort of right-clicking the graph and go into Graph Options and uncheck Draw Visible Spectrum. So you'll want to save this spectra in a Word document for your lab report, and to do that on your keyboard you can hit Function Print Screen. And open up a Word document and paste the object in Word. And save the file so that you can print it off later on. So once you collect the spectra, you then are going to set up the graph for your series of standards to create your calibration curve. We're going to need to set up the graph so that we can record the absorbance and concentration of our solutions. To do that, we're going to go into Configure Spectrometer. And under Collection Mode, we're going to check off absorbance versus concentration and change the units to milligrams of iron per 50 milliliters, since that is how you prepared your solutions. And then you're going to select individual wavelengths under the drop-down menu and click Clear Selection just to remove any other items that might have been previously checked off. And you're going to select the maximum wavelength that you generated from your absorption spectrum. So ideally for this experiment, you're expecting a maximum wavelength around 510 nanometers. So you'll check that off and then click OK. If you get a message popping up asking what to do with your latest run, so your absorption spectra, since you've saved it in Word, and ensure that you've saved it in Word, click No. So now the graph has been set up to collect absorbance and concentration values. And you'll also see some displays on the left-hand side sort of showing the real-time measurement of your sample. So now for the next part of the experiment, we're going to run our series of standards and construct our calibration curve. So to do this, we're going to start off with our lowest concentration of our standard solution, and we're going to work up to the highest concentration. So anytime you change samples, you're going to want to rinse the cuvette out once or twice with the solution that you're going to use to measure it. So just like so, just to remove anything that might have been left over from the previous measurement. And then you'll fill it roughly 3/4 of the way. And just give the cuvette a quick wipe. And we're going to place it in our spectrometer. And then when you're ready to take your measurement, you'll then click Collect. And what you should see on the displays on the left side, you'll see the absorbance actively being displayed and a data point showing up on your graph. When the absorbance reading is more or less stable, you'll then click Keep, and a window will pop up prompting you to enter your concentration value. So this one is our 0.05 milligram of iron sample. We'll click OK, and then the point will show up on the graph and also be recorded in the table. You'll then rinse out the cuvette and put in your next solution, and then you'll click Collect again and then click Keep. And you'll keep repeating this for all of your standard solutions. And once you finish collecting your data points, you'll then click Stop. So when you finish running your calibration series, you'll get a graph that looks something like this. We're then going to have the program place a linear fit on our points. And to do that, you're going to click on the button up here called Linear Fit. The graph will then display a line going through your data points and also give you information about your calibration curve, things like the slope and the y-intercept and so on. Make sure that you print screen this graph as well and paste it into your Word file. Once you have run your calibration series, you'll then measure your unknown solution. So we'll take some of our unknown. Again, make sure you rinse out the cuvette with some of the solution. Give it a quick wipe. Place it in the spectrometer. So once you've put in your unknown solution in your spectrometer, the absorbance will be measured automatically in the live display. You'll record this value in your lab notebook and then take out the sample and repeat the measurement for your second unknown flask. Once you obtain these values, you'll be able to use the calibration curve as well as your unknown absorbance values and determine the concentration of iron in your unknown solution.